So, I've been getting a ton of questions about AI lately, and I get it. The terms get thrown around so much they start to lose their meaning. You hear AI, you hear language model, you see demos of what people are calling AGI, and it all just kind of blends together into this one big, confusing tech buzzword. But the thing is, the distinctions between them are not just important, they're actually super interesting and have huge implications for where all this tech is headed. Today, we're breaking down the 10 major differences between language models, artificial intelligence, and the soon-to-arrive artificial general intelligence. It's a bit of a deep dive, but stick with me. We're going to get into what each of these things actually is, how they learn, what they can and can't do, and how close they are to actually thinking like a human. It's easy to see a chatbot write a poem and think we're already living in the future, but the reality is a little more nuanced than that. Understanding the lines between these technologies is key to understanding the products we use every day, and the ones that are just around the corner. We'll also cover the pros and cons of each, because like any powerful new tech, there's a lot of upside, but also some things we definitely need to keep an eye on. By the end of this video, you'll have a really solid, clear framework for thinking about this stuff. No more confusion, no more buzzwords. You'll be able to see a new AI product launch and know exactly where it fits in the landscape, whether it's a specialized tool, a broader intelligent system, or a step towards something much, much bigger. We've got a lot to cover, so let's get into it. This is the real difference between language models, AI, and AGI. Alright, first up, let's just define our terms. Think of it like a set of Russian nesting dolls. The biggest doll, the outermost layer, is artificial intelligence, or AI. This is a super broad umbrella term that's been around for decades. It basically refers to any machine or system that can simulate human intelligence. Problem-solving, learning, decision-making, you name it. This could be anything from the AI that plays chess against a grandmaster to the algorithm that recommends your next show on Netflix. It's a huge field covering a massive range of capabilities and complexities. AI is the whole stadium. Inside that big AI doll, we have a smaller one, language models, or more specifically, large language models, LLMs. These are a type of AI, a specific application that's hyper-focused on understanding and generating human language. Think GPT-4, Llama 3, Gemini. These are all LLMs. They're trained on truly massive amounts of text and code from the internet, and their main job is to predict the next word in a sequence. That simple-sounding task is what allows them to write essays, translate languages, and answer your questions. They are masters of language, but they are specialists. They're just one team playing in the AI stadium. And then, there's the doll we haven't quite built yet, Artificial General Intelligence, or AGI. This is the theoretical next level. It's not just an AI that's good at one thing. It's an AI that has the cognitive abilities of a human across the board. It can learn, reason, and apply its intelligence to solve any problem, just like a person can. It's the holy grail of AI research, a system with the same scope and adaptability as the human mind. So how do these things actually learn? It's pretty different across the board. For most of what we call AI today, the narrow AI, the learning is very structured. An AI designed to identify cats in photos is trained on a massive labeled data set of cat photos. It learns the patterns, the features, the catness, but its learning is confined to that specific task. If you show it a dog, it might get confused unless it was also trained on dogs. The learning process is supervised and the knowledge base is deep, but also very narrow. It's like studying for a single, very specific exam over and over again. Language models take this a step further. Their learning, known as self-supervised learning, is much more general. They aren't given explicitly labeled data in the same way. Instead, they're fed a huge chunk of the internet, and their task is to learn the relationships between words, sentences, and ideas on their own. They learn grammar, context, facts, and even styles of writing just by predicting what comes next. This allows them to be incredibly flexible with language tasks, but their learning is still based on the data they were trained on. They don't have ongoing, real-world experiences. They're essentially a snapshot of the internet from a certain point in time. AGI, on the other hand, would learn completely differently. The goal is for it to learn like a human, through experience, curiosity, and interaction with the world. It wouldn't just need a static data set. It would need to be able to learn continuously, adapt to new situations it's never seen before, and transfer knowledge from one domain to another. For example, learning how to stack blocks could help it understand principles of physics that it could then apply to building a bridge. It's a continuous, dynamic, and holistic learning process that we just haven't cracked yet. This brings us to a really key difference: specialization. The vast majority of AI systems you interact with are what we call narrow AI. They are incredibly good at one or maybe a few very specific tasks. The AI that unlocks your phone with your face? It's a specialist in facial recognition. It can't write you a song. The AI that navigates you through traffic? A specialist in route optimization. It can't diagnose a medical condition. These systems are designed and trained from the ground up to excel in a single domain. They have become so powerful and so integrated into our lives that we almost forget they're there. But they are fundamentally one-trick ponies, albeit very, very good ones. Language models are a bit of a gray area here. On one hand, they are specialized in the domain of language. That's their core function. But because language is such a fundamental part of how we express and structure knowledge, they appear to be much more general purpose. You can ask an LLM to do a huge variety of tasks: write code, draft an email, explain a complex topic, create a story, and it can do all of them pretty well. It feels general, but it's all being done through the single lens of language manipulation. It can't, for example, learn to ride a bike or cook a meal by physically doing it. AGI is the complete opposite of specialization. By definition, it's general. An AGI wouldn't be built for a single task. It would have the ability to tackle any intellectual task that a human being can. It could learn to be a physicist, then a musician, then a chef. It wouldn't need to be reprogrammed for each new domain. It would use its underlying general intelligence to learn and master new skills, just as we do. It's the ultimate generalist, the true jack of all trades, and master of, well, potentially, all of them. So can these things actually think? This is where it gets really philosophical, but there are some clear technical distinctions. Current AI, the narrow kind, doesn't reason in a human way at all. It uses statistical analysis and pattern matching. When an AI recommends a product, it's not thinking, you bought a camera, so you might enjoy a tripod for stability. It's running a calculation. Users who bought product X also bought product Y 78% of the time. It's powerful and effective, but it's correlation, not causation. It's a simulation of reasoning based on data, not a genuine understanding of the concepts involved. Language models are a huge leap forward, but they still fall short of true human-like reasoning. They have an incredible ability to mimic the patterns of human reasoning found in their training data. They can construct logical-sounding arguments, explain their thought process step by step, and connect disparate ideas in a way that seems intelligent. But it's still fundamentally sophisticated pattern matching. They don't possess beliefs, intentions, or a real-world model of cause and effect. This is why they can sometimes hallucinate or confidently state incorrect information. Their reasoning isn't grounded in a true understanding of reality, but in the statistical likelihood of word sequences. AGI is the pursuit of this true human-like reasoning. An AGI would be able to understand context, nuance, and abstract concepts. It could reason from first principles, understand analogies, and demonstrate common sense, that vast implicit knowledge about the world that we humans take for granted. It wouldn't just repeat patterns. It would be able to think critically, solve novel problems creatively, and understand the why behind the what. This ability to reason flexibly and abstractly is arguably the biggest and most difficult gap to bridge between where we are now and true AGI. Let's talk about control. How much can these systems do on their own? For most narrow AI, the autonomy is very limited and constrained. A navigation app can suggest a route, but you, the human, have to decide to follow it and actually drive the car. A spam filter can move an email to your junk folder, but it operates within a strict set of rules and permissions that you or the developer have set. These AI systems are tools. They operate within a sandbox, executing specific commands or functions when prompted. They don't set their own goals or operate independently outside of their programmed purpose. They wait for our input. Language models are similar, but with a twist. They are primarily reactive. You give them a prompt, they give you a response. They don't just start writing essays on their own for fun. However, with the rise of AI agents, we're starting to see a new level of scaffolded autonomy. You can give a language model a high-level goal like research the best cameras under $1,000 and write a summary. And an agent framework can break that down into subtasks, search the web, analyze reviews, synthesize information, and write the report. It's still operating under the user's ultimate goal, but it's taking more independent steps to get there. It's a significant increase in operational autonomy, but still within a controlled environment. AGI, though, implies a whole different level of autonomy. A true AGI could potentially set its own goals. It could identify a problem in the world, formulate a plan to solve it, and execute that plan without any human intervention. Its actions would be driven by its own internal motivations and understanding, not by an external prompt. This is both the promise and the peril of AGI. The potential for self-directed, superintelligent systems to solve humanity's biggest problems is immense, but the challenge of ensuring those self-set goals align with our own is one of the biggest safety concerns in the field. Can a machine be creative? The answer depends on which machine we're talking about. Traditional AI is generally not creative in the human sense. It can optimize, it can analyze, and it can execute tasks with superhuman efficiency, but it typically doesn't generate truly novel ideas. A chess-playing AI might make a move that no human has ever seen, but it's doing so based on a calculated optimization of winning probabilities, not on an artistic or inventive impulse. Its creativity is emergent from its computational power within a defined set of rules, not from a desire to create something new and beautiful. Language models, and their cousins, the image generation models, have completely changed this conversation. Suddenly we have AI that can write poetry, compose music, and create stunning photorealistic images from a simple text prompt. This certainly looks like creativity. These models are incredibly skilled at remixing and recontextualizing the vast patterns of human creativity they learned from their training data. They can blend styles, combine concepts, and generate novel outputs that are often surprising and inspiring. The debate, however, is whether this is true creativity or just extremely sophisticated mimicry. Is it creating something genuinely new or just finding a new combination of things that already existed? The jury is still out on that one. An AGI's creativity would, in theory, be indistinguishable from a human's, or even greater. It wouldn't just be remixing existing data, it would have a deep understanding of the world, of aesthetics, of emotion, and of context. It could generate new scientific hypotheses, new genres of art, new philosophical ideas, not by rearranging old patterns, but by forming genuinely new concepts from its comprehensive understanding of reality. It would be an originator, not just an imitator. This level of generative, conceptual creativity is a hallmark of what would make an AGI truly general. Okay, let's get into the pros and cons, starting with the tech that's having a massive impact right now, language models. The biggest pro is, without a doubt, the democratization of powerful tools. Suddenly, anyone with an internet connection can have a personal assistant, a writing partner, a coder, and a research aid all rolled into one. This massively boosts productivity. People are using large language models to draft emails in seconds, debug code that would have taken hours, and learn new subjects faster than ever before. It's a force multiplier for individual capability, and we're only just scratching the surface of what that means for work and education. Another huge advantage is accessibility. Language models are breaking down barriers. Real-time translation tools powered by these models are connecting people across linguistic divides, in a way that was science fiction just a few years ago. They can simplify complex technical documents into plain English, making knowledge more accessible to everyone, not just experts. For people with disabilities, these models can power assistive technologies, turning spoken words into text or summarizing long articles for those with reading difficulties. They act as a universal interface, making the digital world more navigable and information more universally available. It's a massive step forward for inclusivity in technology. Of course, it's not all upside. Language models come with some significant drawbacks we need to be smart about. The biggest one is probably the issue of hallucinations or making things up. Because these models are designed to generate plausible-sounding text, they can sometimes state incorrect information with absolute confidence. They don't have a concept of truth, only of statistical probability. This makes them unreliable for fact-checking or for tasks where accuracy is critical. You can't just trust what they say. You always have to verify, which adds a new layer of cognitive load for the user. It's a tool, not an oracle. Another major con is the potential for misuse and bias. These models are trained on the internet, a data set that contains the best of humanity, but also the worst. As a result, they can inherit and even amplify existing societal biases related to race, gender, and culture. Without careful filtering and fine-tuning, they can generate harmful, toxic, or biased content. There's also the risk of them being used for malicious purposes, like generating convincing phishing emails, spreading misinformation at scale, or creating deepfake text for scams. The power to generate human-like text is a double-edged sword, and building the guardrails is a huge ongoing challenge for the entire industry. Now let's zoom back out to the bigger picture of AI and the future promise of AGI. The primary pro of current narrow AI is automation and optimization at a massive scale. AI systems are running in the background of our lives, making everything more efficient. They optimize supply chains to reduce waste, help doctors detect diseases earlier from medical scans, manage energy grids to prevent blackouts, and power the financial markets. These systems can process and find patterns in amounts of data that no human ever could, leading to breakthroughs and efficiencies that are quietly improving our world in countless ways. They are the workhorses of the modern economy. The potential pros of AGI are on a completely different level. They're world-changing. An AGI could tackle humanity's most complex and intractable problems. Imagine an intelligence that could develop a cure for cancer, solve climate change by designing new forms of clean energy, or completely revolutionize material science. It could accelerate scientific discovery at an exponential rate. On a personal level, an AGI could function as the ultimate personalized tutor, doctor, and creative collaborator for every single person on Earth, helping each individual reach their full potential. The promise of AGI is not just to make our current systems better, it's to create a future of unprecedented abundance, health, and discovery. It's the ultimate tool for human progress. With that incredible potential comes incredible risk. The cons of advanced AI and AGI are the things that keep scientists and ethicists up at night. For current AI, a major concern is job displacement. As AI-powered automation becomes more capable, many jobs, particularly those involving repetitive tasks, are at risk of being replaced. This could lead to massive economic disruption and social inequality if we don't manage the transition carefully. There are also major ethical concerns around surveillance and control, as AI gives governments and corporations unprecedented power to monitor and influence people's behavior. The potential for autonomous weapon systems is another dark cloud on the horizon. When we talk about AGI, the risks become existential. The central problem is alignment. How do we ensure that the goals of a superintelligent AGI are aligned with human values and well-being? If we create an intelligence far greater than our own, how do we maintain control? A misaligned AGI could, even unintentionally, cause catastrophic harm in the pursuit of a seemingly benign goal. The classic example is an AGI tasked with making paperclips that decides to turn the entire planet into paperclips. It sounds silly, but it illustrates the core danger of a powerful system that doesn't share our fundamental values. These are not just technical problems. They are some of the most important philosophical questions our species has ever faced. So that's the breakdown. As you can see, while we tend to use AI as a catch-all, the reality is much more layered. We have the broad field of AI, the specialized language tools like LLMs that are changing our daily lives right now, and the theoretical, all-encompassing intelligence of AGI on the horizon. Each has a different scope, a different way of learning, and a completely different set of capabilities. They're related for sure, but they are not the same thing. Understanding these nuances is more than just tech trivia. It's about being an informed user and citizen in a world that is being rapidly reshaped by these technologies. So whether you're excited or cautious about the future, understanding these differences is key. Knowing that a language model is a powerful mimic, not a truthful oracle, changes how you use it. Recognizing that most AI today is a specialized tool helps you appreciate its power without overestimating its intelligence. And thinking about AGI forces us to have critical conversations about what kind of future we want to build. The development here is moving incredibly fast, and what seems like science fiction today could be a product announcement tomorrow. It's an exciting, and maybe a little scary, time to be alive. Ultimately, the impact of these technologies is up to us. The choices we make, the products we support, and the regulations we demand will all shape the path forward. It's a conversation that everyone needs to be a part of. On that note, I'm really curious to hear your take. Let me know in the comments which technology you think will have the biggest impact on our lives in the next 5 years. The continued explosion of specialized language models, or the steady, quiet progress of broader AI? Let's talk about it. Thanks for watching, and I'll see you in the next one.